Hello friends, I welcome you all to this session on power plant engineering. So in the previous lecture you have seen that what is a Rankine cycle, simple Rankine cycle, what are the different components of it. So in this lecture what I'll try to do is I'll try to elaborate on the boiling process, that means the phase conversion. So now if you remember uh, that we were having this cycle, this is entropy, then temperature. Now this is your boiler pressure, this is condenser pressure. Now this was turbine, and then this is pump. Now if this is 1, 2, 3, 4 and 5, now process 4, 5, let's say this is 6, 6 and 1. This all was happening inside the boiler. So let us try to understand what is happening where and what are these called and what is the fraction of energy taken up by individual terms. Basically friends, if you look, this 4 is a subcooled liquid, this is subcooled, this is saturated liquid, this is saturated vapor, and this one is superheated, let me write it full, superheated vapor. Now the liquid once enter into the boiler enters as subcooled liquid, then becomes saturated liquid. Now this conversion of subcooled liquid to saturated liquid is done in the economizer. So economizer is basically that portion of the boiler where the conversion of the liquid from subcooled to saturated liquid happens. Okay, and here the temperature of the fluid, that is water, rises. Then comes 5 to 6. Now this is where the phase conversion happens at constant pressure, and this is done in basically the evaporator portion of the boiler. Evaporator. Here the phase conversion from saturated liquid to saturated vapor happens. Okay, so this is your evaporator section, and after it becomes fully saturated vapor, then whatsoever energy we are giving to it will result in increase in the temperature of the vapor, and that is being done in the superheater. So in superheater, that saturated vapor will convert into superheated vapor. So the conversion from saturated vapor to the superheated vapor is happening where? In the superheater. Okay, so this basically whole is what we call as our boiler. So now if you try to find out the heat transfer in case of let's say economizer, that will be nothing but enthalpy rise from 4 to 5, that is H5 minus H4. Then the heat transfer in case of evaporator will be from 5 to 6, that is H6 minus H5, and the heat transfer in case of superheater will be equal to from 6 to 1, that is H1 minus H6. So these are what? These are basically the heat transfers in different components of boiler. This evaporator heat transfer is also called as latent heat transfer. So the heat transfer in the evaporator is nothing but latent heat. Means the amount of energy transferred during the phase change of a substance, that is from 5 to 6, where the pressure as well as temperature doesn't changes. Okay, now this particular latent heat portion is a very sensitive portion towards the pressure. Why? Because let's say this is my TS diagram, and let's say this is some pressure. Now if I increase the pressure to this, then if you try to find out what is the area under this, then you'll be able to see that the area under this has reduced, and that has resulted in reduction in the latent heat, or ultimately the heat transfer which is happening via evaporation, that means in the evaporator section, has reduced. So as we move up and up to higher pressure, the fraction of the energy transferred in the evaporator reduces. So what is the fraction? That means total energy taken up by the evaporator. That means if I come back, it is H6 minus H5 divided by the total, that is this was 1, this was 4, so H1 minus H4. So this particular thing will reduce as we move up. So as the pressure increases, the amount of energy transferred in the evaporator reduces. And you also must be knowing that there are power plants which are known as supercritical power plants. So there you won't be having this particular phase conversion zone. So directly the vapors, there will be a liquid, and after this point there will be vapor. So no phase conversion zone. Only a portion will be there which is called as separator. During the starting phase it will be working. Okay, so this is what will happen. And you should also know that in any high pressure boiler, more than 40% of the total heat, more than 40% of the total heat is absorbed where? In the superheater. You always remember. So more than 40% of the total, that is H1 minus H4, will be taken up where? In the superheater. This you should always remember. Okay, so in this lecture, till this point only. In the next lecture, what we'll be learning about the different types of irreversibility which happens in case of inside the Rankine cycle, due to which the performance reduces. So thank you very much for watching it.